is Dr. Ulrike Yang, who leads the Mathematical Algorithms and Computing Group at CASC, the Center for Applied Scientific Computing at Lawrence Livermore National Laboratory. Ulrike.
Okay, thank you. And Samir, I would like to thank you for your invitation. Maybe share my screen for my presentation. Okay. Okay, can you see it?
Yes, we can. Yes.
Okay, good. So yes, I will get to talk about the first SDK. I know Mike, Haru, and other people have mentioned SDKs in previous talks. And so I will get to talk about the current state of the xSDK. So as I said, this is really important. What's important is to build an effective ecosystem for exascale. And exascale, of course, is a very huge number, as you can see here, and everybody knows here. And as Mike and other people already mentioned, there are 3 exascale computers planned in the United States. That's Aurora, Frontier, and El Capitan. And of course, because they do have these heterogeneous node architectures, they do present a lot of challenges, as a lot of people have already mentioned earlier as well. Particularly, they do have GPUs and CPUs. They require different programming models, and they do have additional, more complicated memory hierarchies. So it's very challenging, and particularly I'm representing the xSDK, the SDK for the math libraries. This means that all the math libraries have to work really hard to make sure that they're actually capable of porting to these new machines. Of course, one of the advantages of these great machines is that they will enable much larger simulations for more sophisticated application codes. And so they will ultimately lead to better science. So we are all very excited about this in the future. So these big application codes that are getting more complicated, of course, do need mathematical algorithms. And that's where the xSDK or our math libraries really come into place, because it is really important that they all work fine for them and that they can actually use them. And so that's why we need an effective ecosystem to make sure that these applications really deliver the great science we're looking forward to. So what is an ecosystem? An ecosystem is a group of independent but interrelated elements comprising a unified whole. And they are also very challenging. As a matter of fact, Sir Arthur Stanley Eddington, who was an astrophysicist, but also somewhat a philosopher, he said, we used to think that if we knew 1, we knew 2, because 1 and 1 are 2. But we are finding that we must learn a great deal more about and so that's really the issue with ecosystem, as we have to try to figure out how are they actually working together in combination. In other words, our math libraries, they won't do the application teams no good if they're unable to try to build them together and do things. So on top of it, we do want to have an effective ecosystem. So we want it to be effective. And if we stick with the idea of 1 and 1 equals 2, I'm claiming that if you have an effective ecosystem, actually you get this. You get 1 + 1 is greater than 2. You get something better. Or to express this in different terms, which maybe people feel more comfortable with, the impact of the whole ecosystem, assuming it's effective, of course, is greater than the sum of the impact of the individual elements. So, as I said before, we are talking here about the xSDK, which stands for Extreme Scale Scientific Software Development Kit. And it is a system of interoperable math libraries that are, however, independently developed. And that's where the difficulties come in. We want to make sure they can be used together, that there's also a certain interoperability between the different libraries, and they are needed to support all these different problems and application codes that come. Here you actually have a picture of some extreme scale science applications, and on the bottom you see the xSDK. So let me give you a brief outline of my talk. First, I want to briefly speak about the history of the xSDK. Then I talk about the individual elements of this xSDK ecosystem. I also talk about what is required to be effective. We'll say a few words about the impact the xSDK already had on applications, and end with future plans. So getting back to the history of the xSDK. So the xSDK actually, or I should say overall, the whole concept started in September 2014 in the IDEAS project, which stands for Interoperable Design of Extreme Scale Application Software. And this project was actually led by Mike Carew, Lois McInnes, and Dave Moulton, and was a partnership between two offices of DOE, the Office of Applied Scientific Computing Research and Biological Environmental Research. And they wanted to, BER was interested in making sure to get some terrestrial modeling done, and which required some big application counts. And on the ASCR side, we were dealing with various math libraries. And already at that time, there were issues just trying to build this together. Even so, at that time, we only actually had 4 math libraries and 1 domain component when we started. So there were issues with namespacing, interoperability, problems, things like that. And so the original project consisted of 3 parts: the terrestrial modeling, the use cases. We did have methodologies, which were starting to understand what does it actually mean to gain software productivity. And finally, there was the xSDK. That project actually ended in September 2017, but before that, the ECP started. And so the xSDK is continued on in the ECP, which actually started in October 2016, so there was an overlap. And there's also an IDEAS project, by the way, in the ECP, which will more look into methodologies and other things of software productivity. So the xSDK is very important because it is the key delivery mechanism for the ECP math libraries. And so it is really important on our end to make sure that we are able to provide a robust build, that we do have highly efficient libraries that work well on the upcoming machines, that need portable and sustainable, and they need to have a high software quality. So the first release came out in April 2016, and you can see here, at that time, we had 4 math libraries, as I already mentioned, and 1 domain component. You see the green ovals there, and the brownish one, Alchemia. And we did have an xSDK installer that was based on Petsi. We also had community policies, and I'll talk more about this. We had 14 mandatory community policies. I should say, most recently in 2019, that's a year ago, we actually increased this to 21 math libraries. You can see them here. Actually, we omitted the interoperability arrows because it would have been too hard to see anything. We have 2 domain components at this point. We now have 16 mandatory community policies. And actually already with the second release, we started to switch to SPAC as our xSDK installer, which has served us well. And you heard about SPAC earlier. So, so now, as I've talked about the history, I want to talk about what are the actual elements of the ecosystem, the xSDK. First of all, of course, they are the math libraries. And libraries are important because on the user point of view, they are able to just use the algorithms and data structures underneath without having to worry about the little details of complicated algorithms. No, I have to worry about porting them to other systems. And as long as the library is of high quality, things will work well for them. On the developer side, we are very happy also to talk to application users because for once, we're always happy when we know people are using our work. But on the other hand, we also get better code if we have more people using it because they will report any issues they have very quickly generally. That allows us to improve our codes. And they also give us new ideas on additional options we should add to our libraries to be more useful for the application. So there is a lot of benefits to work together, and the ECP is really a great place to do that. As it already started in the IDEAS project where we had this work together, but now we have a lot more libraries and a lot more applications available. And so the ultimate idea is to keep working, improving our productivity, and ultimately get better science. So here are the current xSDK libraries. I said there are 21 of them and 2 domain components. You see their logos on the left side, and on the right side, there are a variety of mainly the contact people for the libraries and it's some additional people who are working on this. But this is not all of them. There are a lot more people involved to make sure that these libraries actually still work well. So another important element of our ecosystem is the package manager, and that's SPAC. And I know various people have talked about this besides Todd himself talked about SPAC earlier. And SPAC is a very flexible package manager. As a matter of fact, on the right here, you see a dependency graph that was generated by SPAC of the latest xSDK release, where you can actually see the green ones are the member packages, xSDK libraries, and then the black ones are third-party libraries they're relying on. So you see it is actually already very complicated to try to build all this because all these different pieces need to be built. And so the nice thing about SPAC is you can deploy the whole xSDK just by SPAC install xSDK. Of course, generally you might not want to have all of them, only a subset, but you can also do this with SPAC, trying to build subsets of this. Here are just a few things that you've seen earlier already, although I have to say when I saw Todd's talk earlier, I realized that numbers have grown, and I should say these results he only gave to me in July, and I decided to leave the numbers here. They are of course true, they are over 600, but in Todd's talk there were 650 and over 4,700 and 4,300, and I decided to leave this in there instead of asking him to update, just to let you know how quickly SPAC is actually growing. In just 3 months you have so many more contributors and software packages. Okay. Another element besides the libraries and the package manager are the actual community policies. And I mentioned them earlier. They are really important because they make sure that the individual packages, as long as they follow those policies, are really capable of building well, of being interoperable, and to have very good software quality. And they are available actually on the xsdk.info webpage that are listed up here, which has a lot of information on it. We actually made a change last week to them, so probably there's not the newest information on that webpage yet. However, as a matter of fact, I'm sure there isn't. As a matter of fact, however, if you want the newest version, it's best to go on GitHub because we are now releasing the community policies regularly, and there are ways of influencing them by going to this GitHub webpage. So, and there you can see our newest version, as well as discussions we've had on changes we want to make. So what are these community policies about? So if a package would like to be compatible with the xSDK, then they must satisfy a mandatory xSDK policies, which there are 16 of them right now. And the topics that they involve is to make sure they can be configured well, they can be installed well. They also need to be able to have a test suite. So there needs to be constant testing going on to make sure that these libraries don't break. There's rules regarding MPI usage, regarding portability to various platforms, especially besides Linux and Mac. Linux, of course, is important, but there are also portability to important computers at the leadership facilities, because that's where most of our customers want to run their codes. There needs to be useful contact information, something that really gets somewhere and doesn't end up somewhere in a space, and version information. Open source licensing. So we would like to have a very permissive open source license. So that's important. And then, of course, to avoid namespace conflicts, etc., and have repository access is also important to be able to actually build the xSDK. We also do have a number of recommended policies. There are 8 of them now. As a matter of fact, R8, which I made a little blue, is a new one. We added it last week. And the topics include public repository access. So we would like to have a recommended public repository, error handling, also rules regarding how to free system resources, as well as library dependencies. And finally, the last one we just recently added is on documentation quality. So it is important for the math packages to have good documentation so users can use it, etc., as well as rules for developers to make sure that they know how to add to these packages, because they're all open source, and so people can add options to libraries, etc. So in order to have an xSDK member package, to become a member of the xSDK, the package does not only need to be compatible with the community policies, but it also needs to use or used by another package in the xSDK. And then also that interface needs to be regularly tested for regressions. So the last release of the xSDK policies was in June 2019. And we plan to have another one coming up with the next xSDK release, which is due in mid-November. And so we are currently still working on additional things. And I'll talk more about this a little bit. Of course, the overall idea is that we want to make sure that code improves and interoperability still work, etc. Code is sustainable and so on. And we really encourage feedback and contributions. So please, if you have anything to say about these community policies, they did not get developed in the vacuum. We got a lot of input from the community. So yes, we are working on adding, changing, and retiring community policies when we think it's necessary. And when we do so, as we're doing right now, as a matter of fact, we try to get community input. As I said, this information is available up on GitHub, so you can see some of the, you can definitely see the discussions we had. As a matter of fact, if somebody wants to change something or add a community policies, etc., they can make a pull request on GitHub. And then we will start discussing this and work on it. And once we have a sufficient number of people agree on this and not really any serious points against, we will actually adopt it. So as a matter of fact, last week we adopted the policy on documentation quality. Again, so. Oh, I realized I forgot to add a slide here. So one thing I do want to add, so let me just go back, that we're actually working right now on M1 as a policy on configuring. And what happened there is right now, it also includes actually 13 installation policies. And the current M16 also has something to do with configuring. And one of the issues we're currently discussing is the fact that we are we're trying to make M1 a little easier, because it was originally developed when we still had the Petsi-based installer, but now with spec, a lot of things are getting easier. And so we're trying to reduce a lot of the, for example, want to get rid of the installation policies, etc. So there's a lot of discussion going on this right now, and we expect this to be included when we release the next version of the community policies, that things will be a little easier and a little more useful for Python packages, for example, because at that point, things were more looking towards C or C++ packages or Fortran packages, and not so much Python. Okay. So, so what is required for the ecosystem to be effective? So the points we're looking at here is, of course, software quality. Obviously, our individual math libraries need to have software quality. They need to be sustainable. They need to be interoperable, and they need to have portability. And again, these are all points that are addressed in our community policies. So, for example, policy M2 says provide a comprehensive test suite, which is important to make sure you have good software quality. Also, M9 says use a limited and well-defined symbol macro library and include file namespace, again, to avoid clashes with other libraries. M15 says that all xSDK compatibility changes should be sustainable. We do want to make sure that members stay members and not fall out of the xSDK, and they keep their quality, sustainability. Interoperability is another challenging part, but an important ingredient of the xSDK, and there are different levels. Level 1 means that the packages can be used side by side. 2 means that libraries exchange data with each other. And 3 means that libraries can call the other library to perform unique computations. And you can see some examples here on the right of different libraries calling each other, and have a multiphysics application C underneath 2 individual applications, and how they might call different xSDK libraries, and how important it would be for application C to be able to have all these libraries work well together and build well together. This is just the current interoperability between packages. Again, in yellow are interoperabilities that exist, and blue are interoperability exists but enabled in SPAC. And essentially, to be an xSDK member, we expect each one to either have 2 points in the column or in a row, because the rows say which library package on the left, like AMRX, depends on versus the columns say where which packages call these libraries. So the packages that call this library. Okay. To make this easier and also give a user some better idea on interoperabilities that exist, we actually designed a suite of example codes that demonstrate interoperability. And this is also available on GitHub. It's called xSDK examples. And the packages that are listed in this little skit on the right are the ones that are currently included in this example code suite. Again, they demonstrate interoperability, and users can see how maybe certain packages will interoperate with others. But on top of it, they also allow us now, especially as we have a new release upcoming, to use this for testing after we've actually built the release to make sure that at least those codes will work together. And so it's a nice feature to have in addition. Obviously, we will plan to add more as time goes by and add also more interoperabilities. Portability, that's really important. And I know we had a very nice talk earlier on efforts to be made at portability. Again, there is another community policy, M4, says give best effort at portability to key architectures. So what are the efforts that xSDK libraries make to actually be portable? So one portability strategy is to use a portable programming model that provides the abstractions. Of course, you heard a talk earlier about Cocos. Trilinos is one of the libraries that takes advantage of Cocos. Other similar programming models is Raja, which Sunrise is one of the libraries that uses Raja. And of course, there are other ways of OpenMP5X, OpenCL, etc. Okay, another strategy is to limit the code that interacts with the devices. If you have if you directly call any of these codes. So there are different approaches here, like Sundials define some data structures, the abstract data structures that helps them to reduce the amount of code. Deal2, which only has 151 lines in 16 files of the 700,000 code that contain CUDA calls. Again, it's really important. That allows them to just work on these individual. And finally, here I want to mention Gingo, which is actually architecture agnostic. And Hardwick provided me a very nice graph here, where you can see their core is architecture agnostic, and then they have a runtime polymorphism underneath that picks the right kernels depending on the architecture. And currently, they have options of OpenMP, CUDA, and HIP, and I'm sure they will be working on adding more to also be able to run on Aurora, etc. Another library, Petsi, has a similar performance portability strategy. They use abstract vector and matrix classes. You can see underneath they're calling OpenCL, which is Vienna CL. It's a GPU independent, so it's really up to those Vienna CL guys to make sure that Petsi can connect to all these different programming models underneath, but they also provide CUDA. They also take advantage of CUDA, HIP, and Intel kernels, and they allow user code to be written in these programming models. I think that's still work in progress, so to make it more portable. Again, fast kernel libraries are useful to many other libraries as well to try to make sure we do take advantage of them, like WhoSparse for NVIDIA, ROCm for AMD, or MKL for Intel. Finally, a lot of us do write our own CUDA kernels, and our plan is to use vendor-provided tools to port these kernels, like hippify them, or use data parallel C++ for Intel GPUs, and hopefully these things will work as well as we hope they will do. And finally, another strategy, which maybe is the most exciting one and challenging one, possibly can lead to the best results, is to develop new algorithms that are more suitable for GPUs. But again, there might not be enough time to do that. Okay, impact on applications. So the xSDK is used by many different applications. For example, for integrated surface-subsurface hydrology models, which were the original tasks we looked at under the original classical ideas project. At that time, here's an example of recent simulations that were done, and that used the xSDK libraries Petsi, Trilinos, Hyper, and SuperLU. And all the changes we did to make during the classical ideas project and since have paid off. So they were able to do a nice simulation here. And you can see here the surface plot that shows the depths of the ponded water, and underneath you see the subsurface. And again, this gives them a lot of insight on how the water moves and arrives at a given point of time, which is important. Of course, ECP applications is our big target right now as well. And so there's the ExaWind project, and I just give you a few because there are, of course, a lot more applications than these ones. We're working on complex flow physics in wind farms. They currently use AMRAX, Trilinus, and Hyper, and they're starting to integrate sundials, magma, and SuperLU as well. Then there's the WDM app, which is a high-fidelity whole device model of magnetically confined fusion plasma. And they're actually working on tokamak geometry, etc. And they use Hyper, Petsi, Magma, SLEPC, and SuperLU. And then the CoDesign Centers, also very interested in the ECP, COPA or SEED. I just have here a few illustrations that Tanya Kolev gave me of the SEED Center. For them, the xSDK is highly relevant because they do have a lot of applications they support. And SEED actually uses or plans to use the following libraries. You see there are 9 of them: MFEM, Magma, Hyper, Petsi, Sundials, SuperLU, Gingo, Kumi, as well as StrongPack. And you see they have all kinds of different radiation hydrodynamics, wave scattering, etc. They do have a lot of different applications they use. So what are our future plans? So for once, we are already working on this. We are working on updating the xSDK community policies. And so as I mentioned before, we already added a policy on documentation quality, and we will restructure M1 and M16 to make it more specific to SPAC and make it a little easier. And I have to say that some of this was inspired by the recent generation of the E4S community policies that we're in the process of developing. So it's a bit funny because E4S used the xSDK community policies as a starting point and then started to change things because different XSDKs, different SDKs like tools, etc. that are out there, they do not need all of the library policies, which are important for us and so on. But they also had a chance to really think about what is really needed and how can we make it a little simpler. So we're trying to make sure that this is the case for us. As I said before, we will have a new release coming out in November. We do also want to increase interoperability in example codes, and we also plan to add special options. So again, there's our webpage for xSDK info, also our webpage for community policies, etc. Again, please give us feedback. And I just do want to mention that it takes a really whole world to a whole kinds of people to make an eco project, an ecosystem. So as you can see here, this is the amount of people that are all currently working on the xSDK ECP project, and that's not even all the people who have contributed to that. As you can see on the left, on the bottom, these are all the institutions that are part of it. And so I have to thank all these people for doing the great job they're doing and being helpful. And we do have some sub projects as well. So I want to thank you for listening and let me know if you have any questions.
We have a question from Martin Schulz.
Okay, hi Martin.
Hey Ulrike, thanks for the talk. It was interesting. I just had a question regarding the community policies around MPI. Have you had a chance already to look at MPI 4.0 and how this would affect the policies, particularly the sessions, which bring a new way to initialize libraries?
That's a very good question. And no, we actually haven't. So yes, we should do that. So I appreciate that thought.
Well, if I can help, let me know.
Yeah, I'll send you an email.
Okay, thanks.
Any other questions?
Thank you very much.
Okay.